Good morning, everyone. My name is Shravan Kumar from Delsoft Technologies. Today, I'll be demonstrating NetSim network simulator and its various features and functionalities. Now, this tool allows user to design, analyze performance, and validate networks, and also permits the user to edit the network protocol. So, first, we go through the slides one by one and show you features. So, why we use NetSim or any other network simulator? As you know, with the advancement of technology, newer protocols are being drafted very frequently, and it is very difficult to keep abreast with the latest happenings. So, moreover, analyzing network behavior using traditional analytic methods has become very cumbersome. So, it is not easy to manually analyze the network. So, considering the fact that large number of parameters are involved, so we need such kind of network simulator that can be used to provide an accurate understanding of network behavior and its associated problems and solutions. Now, NetSim introduction. NetSim is a scientific tool for designing and validating networks and protocols, and hence it has a lot of relevance in protocol research and development. And in defense, for instance, it is used for simulating network-centric warfare. It has wide range of technologies which is possible to simulate in NetSim are Internetworks, which includes LAN, WAN, and wireless LAN, mobile ad hoc network, WiMAX network, cellular network, which consists GSM and CDMA, cognitive radio, LTE, wireless sensor network, which includes ZigBee, and it has NetSim has two versions. One is academic version and one is standard version. So in academic version, we can design and simulate various kind of networks, but in standard version, we can edit the protocol, where users are provided with C source code of the network protocols, which is being implemented based on IEEE and IETF standards. So the purpose of this is to enable users to edit the standard protocol code according to their own implementation, and they can link it with NetSim and analyze the performance of their newly designed protocol. Okay. So now NetSim has some customer segment, that is enterprise, defense, R&D labs, and academic. It is being used in these segments. Okay. So in defense lab, it is being used for network-centric warfare simulation. Enterprise, it is used in network design, network validation. R&D labs, it is used in protocol development, new technology testing. In academic, it is used in network labs or in MTech for thesis and projects. Now, NetSim architecture. This architecture provides you a holistic view of NetSim, where users will design the network and configure it in GUI interface, so which will be further simulated by NetSim engine and thereby providing multiple metrics regarding the performance of the simulated network. So user is not required to write any script or code while designing and configuring the network scenario. So this is one of the most striking feature of NetSim, which is the NetSim engine itself. So as you can see, it is utilizing a virtual network stack which actually mimics the real world TCP IP stack, and hence it makes it very easy for any user to edit the protocol and also get fairly accurate result. So users can use further for cross layer protocols like leech. So for designing any network, you can use it for GUI. It will further configure your file in XML format. It is being further simulated by virtual network stack, and it will create some matrix files, event trace, packet trace. These are being results that been simulated after that. Okay, so this is the overview of the network stack. Now these are some components. Actually, this NetSim is divided into these components. So the first component is the base component, which is required for all the components. Okay, so it has internetworks, that is Ethernet, fast and gigabit address, ARP, wireless LAN, and these are the features of routing, RIP, OSPF, queuing, and there are some common module application. In NetSim, you can generate various kind of traffic on any node like voice, video, FTP, database, HTTP, email, peer-to-peer, custom. These kind of traffic you can generate on any node. Okay, After that, it will create some metrics engine with packet trace and event trace and the packet animator. So this is the some common module application which is available in both the versions, and these are being implemented according to the international standard, that is IEEE RFC. Okay. So in component 2, it has legacy network, that is Aloha, pure slotted Aloha, CSMA CD, token ring, token bus, ATMs, frame relay, multi protocol label switching, MPLS, and this is according to all the standards of IEEE. Okay. Component 3 has BGP networks, border gateway protocol. Component 4 has advanced wireless network, that is MANET, which contains DSR, AODV, OLSR, ZRP, WiMAX protocol. Okay. Then component 5 is there for cellular network, that is GSM and CDMA. And component 6 has wireless sensor network and PAN, personal area network, with their agent model and battery models, ZigBee. And for component 6, component 4 is required to run this. Then component 7, which is cognitive radio network, that is WRN, wireless radio area network. And component 8 is LTE, long term evolution. And component 9 has military radio, TDMA link 16. Okay, so these are the components implemented in NetSim. Now, what's new in V8? So this current version has some upgradation in LTE, like LTE, uh, some OFDM for downlink, SCFDMA for uplink, MIMO for their enhanced throughput. These are some features that has been upgraded in LTE. Then dynamic metrics is there. In dynamic metrics, there are some UI property model that can be extended by XML files. Then some custom properties are there where you can edit the properties of the devices through XML. Then BGP cellular network with stack, that has some BGP protocol updated. Then some new application models, uh, that is traffic has to be generated. So these peer-to-peer email and HTTP have been upgraded. Now NetSim hands-on. So while working on NetSim, it is being divided into two parts. One is model, simulate, and analyze a variety of network, and part two, write your own code and link it to NetSim. Okay, so we'll go one by one. In part one, we design the network. Okay, you have available with all the nodes, links, wired and wireless. You can drag and drop your components and connect it and design the network. Okay, then configure the network. After designing the network, you'll edit those properties that is available. Some properties are default and some has to be changed, so you can change according to your requirement. After that, model traffic. So you can generate various kind of traffic on any node. If you want to generate custom type of packet, then constant type of packet, HTTP, email, various kind of traffic you can generate on any node. Okay. Then simulate. After the configuring the network, you will simulate the network for getting the result. Now the summary. Now summaries, you can see in the screenshot. So there are some network given here, and you can see this nodes and links available. And here application tab has been clicked with, and application type is written there, CBR, custom, email, HTTP, video. This kind of traffic can be generated. So it is very easy scenario. You can just click and drop. You can right click on properties, then generate the traffic like voice, video, FTP, HTTP. These kind of traffic you can generate. Then you can start with the NetSim through CLI interface, command line interface, or XML based config files. So when you do any program in NetSim, it will create an XML file. So we usually prefer XML because it is quicker for understanding, it has better presentation, it is automatic format for verification. So we'll prefer for XML only. Now analysis. In analysis, after the simulation, it will give you a performance metrics. Now performance metrics has some various integration in that. So, after that, it will give you packet animator. In packet animation, you can see the packets moving from one node to another. Now in performance metrics, as you can see, these 5 kind of metrics has been created: network metrics, application metrics, link metrics, protocol metrics, and device metrics. Okay. So this network metrics allows user to view the values of the metrics obtained based on the overall network. Overall performance of the network is given in the network metrics. Now application metrics, it displays the various metrics based on the application running in the network scenario, like throughput, delay, and etc. Okay. Now link metrics. Link metrics displays the value of the metrics related to each link, like packet transmitted, packet errored, and collided. Okay. It will give you the information of the link. In protocol metrics, it displays the protocol-based metrics which are being implemented in network scenario, and it metrics will vary depending upon the type of network simulated. In this case, you can notice TCP metrics, IP metrics, OSPF metrics. Now device metrics, it displays the device related metrics like ARP table, IP forwarding table. Okay, so these metrics are available after the simulation. Now you can see the packet animator in the screenshot. Some packets are moving from one node to another. Here you can increase or decrease the animation speed, and it will give you the simulation timing. Whatever simulation timing you have set in the simulation, the animation will run through it. Okay. So there are color variation for control package, data packet, and error packets. Node mobility is there. Animation speed you can control. Play, pause. Everything is available. Okay. So now, as I've told you that this software has two versions. One is academic version, and one is standard version. So whatever I've told you, that is available in both the versions. Now some of the analysis which is exclusively available in the standard version only. Yeah. Traces. First is traces. Now traces are of two types. One is packet trace and one is event trace. Okay. So in packet trace, it logs a set of chosen parameters for every packet as it flows through the network, such as arrival times, queuing times, departure times, payload, overhead, and error collision. So it will give you the performance validation, statistical analysis, and custom code debugging. So there are two screenshots you can see. This one is the blue one is the packet trace, and this one is the event trace. So these are some packet information, and has the event information. Event trace, it records the every single event that is associated with the information, such as timestamp, event ID, event type, device ID, and protocol name. So this will give you the information of packets and events performing in the network. Okay. Now dynamic metrics. Dynamic metrics, it allows user to monitor the value of a parameter over simulation timing. So this is very essential for researchers to understand the behavior of a network at any instant of simulation timing. Link throughput, application throughput, and TCP congestion graph can be dynamically plotted, and these plots can be done during offline or during the simulation. While running and during the simulation, it will slow down the simulation. So we'll choose to perform it after the simulation only, in offline mode. Now Wireshark. As you know, Wireshark is a free and open source packet analyzer, and it is used for network troubleshooting, analysis, and communication protocol development. So in NetSim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packets and transmits it within the simulated network. Hence, Wireshark can be used inside NetSim to capture these packets at multiple node location and perform further analysis. Okay, you can see some screenshot. This is a real-time packet capturing, and these are some graphs, that is RTT and window scaling graph that is available. Now, as we have divided this hands-on practice of NetSim into two parts, part 1 is completed. Now we go to the part 2, that is development platform, that is available in standard version only. Here you can see writing custom code. So NetSim has provided all the existing protocol in the program. You can go in the Visual Studio and edit those protocols. So here in screenshot there is an example of Hello World that I'll show you in, further. It has printed Hello World in this program, and when it is linked through NetSim GUI, first when you run the simulation, it will first print the Hello World, then it will go to the simulation. So and these custom codes are available in NetSim installation directory. Okay. And NetSim has also provided some APIs for protocol developers that will help in the protocol development. There is packet-h, stack.h, list.h, NetSim graph.h, IP addressing.h. These are some APIs available for protocol developers. Now NetSim has 300 plus customer database for 15 countries in different domains like defense, education, international in India. These are some users. Now we go to the software and show you how we can work on this. This is the software environment. The first window will appear after opening the software, and it has simulation, programming, utilities, help. In help, user manual is provided, and source code help is there. NetSim experiment manual is there. 24 experiments are given. You can do all the experiments, perform. Utilities are available. You can log in as a administrator or user. You can define the users in between. And programming is there. So there are some set of protocol experiment that is programming and GUI both. And for running the simulation, you have to go for simulation, new, Internetworks, legacy network. In Internetworks, you can design wired and wireless network. In legacy, there are pure Aloha, slotted Aloha, traditional Ethernet. These are available in legacy network. Then advanced wireless network, MANET and WiMAX, and BGP network is there. Cellular network, GSM and CDMA, wireless sensor network, personal area network, that is ZigBee, cognitive radio network, LTE network. Okay. So we'll do the Internetworks, show you how it will work. So this is the software environment we have to work. Here you can see some of the nodes available here, and some of the nodes are cross. That is not available in this network because this base station, wireless sensor network, sync, wireless sensor network, agent. These are the available for cellular networking and wireless sensor network. So we have selected Internetworks. So nodes related to those only will be provided. Okay. So wired node, in node there is wired node, wireless node, and these nodes are disabled as these doesn't belong to this. So we just drop wired node and create one network. We'll take some switch and router, then one access point to connect some wireless nodes, wired link, switch, access point. Now we'll choose wireless node. We connect it to access point. And we'll connect it to wireless link. Okay. Now we have designed this network. A small network is there. They are combination of wired and wireless network. Okay. So now we have to set the properties for these nodes. When you right click on properties, this is the property of this node. Device name is there, device type of the node, the location. Here Wireshark is there. As I've told you, we can enable Wireshark on any node and it will show you the real-time packet capturing. So I'll just enable one of the node to show you the real-time packet capturing in Wireshark. So I've set it to online. Now in transport layer, there are TCP, UDP. You can set these values, congestion control algorithm. You can select window sizing. Here, one good thing is there. For all the parameters, there is a information tab given. So if anyone doesn't know what are these parameters, they can choose to have this I tab, and they will get the information about this tab. Okay, congestion control algorithm. You can read and see. In network layer, there is IPv4. You can set the ICMP control polling VPN status. And this is interface, one Ethernet interface, which has network layer that will give you the IP addresses, default gateway, subnet mask, and data link layer is there, and physical layer. So some of the parameters are been has been set to default, and some of the parameters are open for change. So you can change these parameters. You accept it. Like node, there are properties for links. When you click on link, it will give you the link type, link medium, link mode, maximum uplink speed, downlink speed. You can choose to have uplink and downlink BER. You can implement these errors, or you can choose for no error. Uplink propagation delay is there, downlink propagation delay. You can accept. Likewise, there are properties for switch. Global properties common. Now this is for Ethernet interface. So devices has the unique properties for there only. So this is data lake layer. It has some unique features for switches. So buffer size, switching latency, STP cost, switch priority, switch ID, spanning tree, switching mode, store and forward, cut through or fragment free. You can choose from here. You can choose the speed and this physical layer. So you can choose for default or you can change the parameter. I'll set it for default only. Now for router, here also you can enable the Wireshark. Network layer is there. If you want to enable firewall, you can choose to true. So it will set the firewall, and if you disable any node, it will disable. Network layer is there. Then data link layer, physical layer. This for interface network 2. Scheduling type you can define. Okay. So we'll set it for default. Like for access point, this for wireless properties, IEEE standard, whatever you to enable, retry limit, threshold, buffer size, standard you can define whatever standard you want. Okay. Standard channel you can define. We'll set it for default. Now this property for wireless link. This is also point to multi-point. Channel characteristic you can choose. Fading and shadowing, fading only, line of sight, no path loss. Okay. So we choose it for no path loss, accept it. This for wireless node. This is the wireless node properties. So now we have set the properties for the network. Now we have to run the network. Before that, we have to drop down this application tab and set some traffic on this node. So we'll set the traffic on this node, wireless node A, from application. Here we can set the application type like CBR, custom, email, HTTP, all this kind of traffic we can generate. And you click on custom. From source ID 1 to destination ID 6. Okay. You can set the custom type of packet for source ID 1 to destination ID 6. You can set this timing. You can define packet size, its distribution, either it is constant or exponential, its value, and inter-arrival timing. So arrival time of the packet you can define from constant or to exponential. Then value of this time, whatever interval it will come, you can define. Now this is one application. You can add some more application from adding this. Add new application, and you can set the application type for other source and destination. So we'll first accept only one. Here you can see one line that is application has been created for 1 to 6 as a custom type of packet. Okay. Now in standard version there are some features that I told you, that packet trace, event trace, and dynamic matrix. Okay. So in packet trace you have to give the file name. It will save in CSV format, Excel file format. This is storage path. These are the attributes. These are the attributes that will be created after the simulation. This is common attribute. This is TCP. This is wireless LAN. Okay. So we set it. Now event trace. You have to set the event trace name. And these are the attributes for all the events: ARP, fast Ethernet, RIP, TCP, wireless LAN, OSPF. So these are the attributes that will be generated after the simulation. We'll click on OK. Now dynamic matrix. Here you see a plot graph after simulation, during the simulation. So we'll choose plot graph after simulation. And this is throughput for all the links, application, congestion window. Click on OK. Now after setting this parameter, we'll run the simulation. Let's say for 50 seconds. Here you can also choose record animation, play and record both, and don't play and record. So if you don't see the animation, don't want to see the animation, you can choose this third one. That is very fast, but we have to see the animation, so we'll record animation. Click on OK. Now the simulation is running. As we have chosen Wireshark, so Wireshark will open in between the simulation. So Wireshark has started. Here you can see the packet capturing. These are the TCP packets that will be captured during the simulation. Our simulation is running. While running the simulation, packet has been captured. This for real-time packet capturing. After the simulation, we can see some graphs from Wireshark also. As we have chosen the record and animation, so simulation is little bit slower. So now simulation has stopped. Now we get the performance metrics. Like I've told you in presentation, performance metrics as network metrics, link metrics, queue metrics, application metrics, all this information about the network. So in network metrics, your whole information is simulation timing, packet transmitted, packet error, packet collided, and bytes transmitted, payload transmitted, overhead transmitted. Okay, the overall information of the network. In link metrics, there's the information of link only. Okay. So link by link, the information about the packet transmitted, error packet, collided packet, bytes transmitted, payload transmitted, overhead transmitted. Your overall throughput will be available in application metrics, that is throughput of the matrix 0.581996, that is a delay, source ID 1 to destination ID 6. We have sent some traffic from 1 to 6, the packet transmitted is this, received is this, payload transmitted, payload received, throughput. Okay. So we have set the dynamic metrics. So link throughput is there. You can see the graphs of link throughput, link 1, link 2, link 3, 4, 5, all the links. Then application throughput graph. And this is congestion window graph. All these has been created in the dynamic metrics. This is ARP table, ARP metrics, wireless LAN metrics, IP forwarding table. All these are the results that has been generated. Now, first we see the packet animation. Our packets are moving from one node to another. When we play the simulation, this packet animator, you can see packets moving. First it will send the information, then when it will get the acknowledgement, it will send the custom type of packet. Here you can see some the packets are moving in green line. You can choose for faster animation. Or you can slow down. So custom type of packet is moving from 1 to 6. We stop it and go to the further analysis. Now we have set packet trace and event trace also. So we'll see here open packet trace, open event trace. So we'll first open packet trace. So it will directly open this that file ptr44 that I've created. Now here you can see in the Excel format, each and every packet is listed here. Now for better observation, you can choose to set this first row this top row and choose it for filter. Okay. Now I will select, let's say first. So here we can see our first packet, packet number 1 has traveled 4 times. So that is custom type. We have set node 1 to 6. So it has traveled from node 1 3 this transmission layer, okay, network MAC, physical layer, all this information about the packet number 1. packet has been sent successfully. So failure success is given here. Yeah. So all the information about the packet. Like 1, you can choose 2, 3, whatever packet you want to analyze, you can see from here. So 1, 2, 3. So these are the number of packets, their information. So likewise, you can open event trace. Now this event trace, here also some event information is there. Event ID, event type, event time, device type. So here also you can see this. Filter it for better observation. So I select the event number 6. So tell you the information. Likewise, you can choose the events from one by one. Analyze. 6, 7, 8. So now I'll show you one more feature of the NetSim, and then we go to the protocol development part. So there is one more. We have to save this experiment. And there is NetSim Analytics. When you open it, no, this. So it has given various kind of network, that is Internetwork, LTE network, legacy, BGP, MANET, WiMAX, cellular, various kind of network is available. So this is for comparison of various networks. So when you click on Internetworks, you have to browse the matrix file. So after the simulation, it will create a matrix file for every experiment. So let's say we choose the matrix for this one. So we drop down some of 2, 3 Internetworks. Now here you can see I have chosen 4 metrics for the same Internetwork. So we have set different parameters for different experiments. So here when you drop down this, you can see simulation timing is different for all the 4 experiments, and packet transmitted is different, packet error is different, packet collided, and bytes transmitted, payload transmitted, and overhead transmitted. So for the same network, you can vary the parameter and see the result. Okay, this for comparison of the Internetwork. Likewise, you can choose for different network and see the analysis. Now for this is the first part, that is simulation. Now we'll go to the programming, how we can change the protocol. For that we have to go for the installation directory of NetSim. Here in program files, NetSim standard. First of all, NetSim standard. This is bin folder. In this bin folder, all the protocols has been given in DLL format. So this NetSim accept the DLL format only of the protocol. So whatever addition you have given, that has to be saved in DLL format only, and you have to replace those file here, and it will link it with the NetSim. So in NetSim standard SRC folder, there is a simulation. We have made it a copy of NetSim, that simulation folder, so that our original DLL would not affect. So simulation copy folder will open. It has the protocol, and there is a NetSim link here. Here you can see there is a link for Visual Studio. So when you click on this NetSim link, it will open the Visual Studio environment for you, and it will integrate all the protocols available in NetSim. There you can change your protocol and see the result. Here you can see all the protocols has been given: AODV, RP, ATM, cellular, cognitive radio, DSR. All these protocols are given. So when you open one of the protocol like DSR, we have opened. So it has the DSR protocol files, and DSR.c file. When you open it, it will give you the DSR protocol. Here we have changed. We have given printf statement of hello world in this init function of this NetSim DSR. So hello world is printed. So we have to just right click on this and build this file. Okay. When you build it, it will create a DLL file. We have already made it for just save the time. So in DLL folder, there is libdsr.dll is given. Okay, that has been created after the building that. So we have to just copy this libdsr.dll and paste it into bin. So here you can see libdsr libdsr.dll libdsr.default. So this is the original file. We have make it for default for saving it, and copy our libdsr.dll here. So this is our DLL file, and this is the default DLL. We have renamed it just to save it. So now our DLL has given here. Now when we open any DSR protocol implementation, we just open here one MANET. So we just open one MANET file here, MANET configuration. Here we have set 5 nodes and created one application, CBR type of application from node 1 to 5. Now it will work for DSR protocol. So when we run the simulation, let's say for 50 seconds, and click on OK. So before running the simulation, it will first print our hello world. Okay, so you can see in this window, hello world is printed. So we have inserted hello world in the dsr.c file, so that is saved in DLL, and when linked that DLL to this GUI. Now hello world is printed here. When we enter it, it will run the simulation further. Okay. So this is a demonstration just to show you that we can change something in the protocol. So this simulation is running. You can change the speed also. Okay. So this is the demonstration for show you how we can change the protocol. Now we have also set this Wireshark. So here you can see this TCP kind of packet have been generated. So here are some of the graphs available. So you click on conversation. Okay. It will show you some time sequence graph. Click on graph type. It will give you window scaling graph, throughput, RTT graph. This is available in. Then IO graph is available. Okay, you can choose this. Like if we click on TCP, it will give you TCP, ICMP. So we just have to choose this. You can see the files. So these are the features of Wireshark only. So my presentation is over. If you have any query, you can ask me through your mic, or you can write your query in the text box. Hello? 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 Hello, Neeta ma'am? Hmm. You can write your query if you have any query. If you don't have mic, you can write your query. Amal sir? Hello? टिक तो लगा दियो ना कौन कौन है हेलो Hello. हम्म, ये आता रहता है. हेलो. हेलो. If you have any query, you can write me on my email or call me on this number.